As we ended class yesterday, we were to this point where we were talking about the complex conjugate zeros theorem, which basically states if you have one complex number, a plus bi, as a root of a polynomial, then a minus bi is also going to have to be a root of the polynomial. That's true of complex conjugates, and it's true of any irrational numbers as well. If square root of 5 is a solution to a polynomial, then the opposite of that is also a root of the polynomial. Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include those listed. So we have -1, 2, and 1 minus I. Well, if we have 1 minus I, then 1 plus I also needs to be one of the roots of the function. So when we write this out, we're going to get x plus 1 times x minus 2 times x minus 1 plus I, and then times x minus 1 minus I. Now when we simplify this is not very fun to multiply out, but we're going to have to do it. So these first two, these are fairly easy to multiply out. We're just going to get x squared minus 2x plus x is going to give us minus x, and then minus 2 for that red part. Now this one is a little different, and what I'm going to try and do is simplify it a little bit more. If I group x plus 1 together, so we have x plus 1 plus I in this one, and I group x minus 1 together here, so we have x minus 1 minus I. These two trinomials are actually conjugates of each other, so when I multiply them out, I can basically say this is going to be the first term times the first term, what we're going to call the first term x minus 1 squared. And then the middle terms would cancel out. If you took x minus 1 times negative I and x minus 1 times positive I, those would cancel out, but then we'll end up with minus the last term squared. That just makes it slightly easier for me. So now we're going to leave this one as it is right now, x squared minus x minus 2. And this becomes x squared minus 2x plus 1. Minus I squared is minus a -1, so that also becomes plus 1. So now we have x squared minus x minus 2 times x squared minus 2x plus 2. And unfortunately, there's no easy way around this. We're just going to have to multiply. So I'm going to multiply this first term times all three terms first. So we're going to get x to the 4th minus 2x to the 3rd plus 2x squared. Now I'm going to multiply the middle term times everything, and I'll switch colors as I do it. So we're going to get minus x cubed plus 2x squared minus 2x. And now I'm going to multiply this last term times everything in that. So minus 2x squared plus 4x minus 4. Now we just need to combine all of our like terms. So we're going to get f of x equals x to the 4th. We have minus 2x to the 3rd minus x to the 3rd, so that's going to give us minus 3x to the 3rd, plus 2x squared plus 2x squared minus 2x squared, so that's going to be plus 2x squared. Now we have minus 2x plus 4x, so that's plus 2x minus 4. And that would be your final answer for this one. So this one, we have 5 and 3 plus 2i, which means that 3 minus 2i is also going to have to be one of our roots. So I'm going to draw a line to separate these problems. We're going to have x minus 5 and then times x minus 3 plus 2i, and then times x minus 3 minus 2i. So really the hardest part on all of this is getting all of the algebra right. Over here I grouped this one and I made it into complex conjugates. You don't have to do that. You can multiply these out as though they were just two trinomials, but it's just a lengthy process. So once again, I'm going to group this so that it's a complex conjugate. So I'm going to say this is x minus 3 plus 2i. I'm going to say this is x minus 3 minus 2i. So I'm not going to touch this first binomial. So I'm going to leave that as x minus 5. Now these two together, I'm going to say is x minus 3 squared minus 4i squared. And when I simplify that, I get x minus 5. Inside here, we're going to have x squared minus 6x plus 9. Minus 4i squared is going to be plus 4. So we have x minus 5. Oops. Times x squared minus 6x plus 13. And now for, well, distribute there. So first term times everything in that one, we're going to get x cubed minus 6x squared plus 13x. Last term times everything in there, we're going to get minus 5x squared plus 30x minus 65. So combine all of our like terms, and we get f of x equals x cubed minus 6x squared minus 5x squared gives us minus 11x squared. Plus 13x plus 30x gives us plus 43x. And minus 65. I feel like I missed a sign somewhere. But anyway, I think that's right. Now we want negative 1 of multiplicity 3. So what that means is that x plus 1 is our factor, and it's of multiplicity 3. And then we have 3 of multiplicity 1. So that's just x minus 3. This seemed innocent at the time, but if I write it all out, we have x plus 1 times x plus 1 times x plus 1 times x minus 3. So I'm going to do these two first, and that's going to be x squared plus 2x plus 1. And then I'm going to put these two together, and that's going to be x squared minus 2x minus 3. And now we have to distribute everything in those. So first term times everything there is going to be x to the 4th minus 2x to the 3rd minus 3x squared. Next one is going to be plus 2x to the 3rd minus 4x squared minus 6x. And lastly, plus x squared minus 2x minus 3. So put it all together, and we get f of x equals x to the 4th. These cancel out. Minus 3x squared minus 4x squared plus x squared is minus 6x squared. And then minus 6x minus 2x is minus 8x. And then minus 3. So our last one of these, and these are the hardest ones of the day, and it's simply algebra though. So x plus 1, and that's of multiplicity 2. And then we have x. I'm going to subtract it all at once. So if we have minus the quantity negative 2 minus I, that's going to give us plus 2 plus I, which means that negative 2 plus I needs to be our other one because we need the conjugate. So that's going to be x plus 2 minus I if we distribute it all at once. Now if I group these so that we have a conjugate in these two, I'm going to multiply this one out right now. So the blue is going to become x squared plus 2x plus 1. And this nasty thing is going to become x plus 2 squared minus I squared. So this one I'm not going to touch right now. We still have x squared plus 2x plus 1. This one is going to become x squared plus 4x plus 4. And then we're going to have plus 1. So we have x squared plus 2x plus 1 times x squared plus 4x plus 5. So multiply all of that out. So first term times everything there is going to be x to the 4th plus 4x cubed plus 5x squared. Don't know why that's happening. Ooh, didn't mean that. And middle term times everything is going to be plus 2x to the 3rd plus 8x squared plus 10x. We're running out of room. And then plus x squared plus 4x plus 5. So I had to go down there a little bit. So our final answer is going to be f of x equals x to the 4th. We have 4x cubed plus 2x cubed, so plus 6x cubed. 5x squared plus 8x squared puts us at 13x squared plus x squared, so plus 14x squared. Our x terms are 10x plus 4x, which is 14x. And our constant is plus 5. All right, let's get on to some easier things. Graph the following functions to determine how many complex real and real zeros the function has. Well, I already have this programmed into my graphing calculator, and so I need to just select that one, x to the 4th minus 2x squared. So I'm going to select this one, and I'm going to deselect the one down here, and I'm going to graph. Oops, I didn't deselect. Don't look at the pink one. Look at the blue one, and we see that it has one real zero here, and it has one real zero here. So going back to our Smart Notes, we know that it has 2 real zeros. And if it has 2 real zeros, we need to have a total of 4 zeros. That means it has 2 complex zeros. So those are fairly easy. Now let's look at the next one where we have x to the 5th minus 2x squared plus minus 3x plus 6. So now I want to deselect that one. And I want to select that one. I want to officially deselect that one. And graph. So on this one, according to our graph, we only have one real zero. And because we have to have a total of 5 zeros, we must have 4 complex zeros. Polynomial function of odd degrees. Find all of the zeros and write a linear factorization of the function. Well, I'm going to start with my calculator. So x cubed plus 4x minus 5. So I need to select that one and deselect that one. So we see that we have a root at 1. So let's put that in. So we have 1, 0, 4, negative 5, 1, 1, 1, 1, 5, negative 5. So that gives us x minus 1 times x squared plus x plus 5. So we need to find those other 2 roots that exist for this, and we're going to do Pythagorean theorem. So we're going to get negative b plus or minus square root of b squared minus 4 times a times c all over 2a. And this simplifies to negative 1 plus or minus the square root of negative 19 all over 2. And so to put that in complex form, it becomes negative 1/2 plus or minus the square root of 19 over 2i. So that's our other two roots. So write the linear factorization of the function. So we're going to have x minus 1 and x plus 1/2. We'll do the positive one first, so that becomes minus square root of 19 over 2i. And then our other factor is going to be x plus 1/2 plus square root of 19 over 2i. Alright, this last one, let's go to our graphing calculator and select that one. So we have zeros at -1 and 1. So when we plug in 1 and we do our synthetic division, we get 1, 1, 5, -1, -6. So 1, 1, 2, 2, 7, 7, 6, 6, 0. Now I'm just going to go straight into the next one because I know that -1, -1 is also one of our solutions based on our graph, and so I'm going to go straight into this one. So I'm going to bring down 1, that's -1, 1, -1, 6, -6, 0. So what we're left with is we have x minus 1 times x plus 1 times x squared plus x plus 6. And we need to find the solutions to this, and that's going to be -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's 1 plus or minus the square root of -23 all over 2. So this is 1/2 plus or minus the square root of 23 over 2i. And our other roots are 1 and -1. So our linear factorization of this is going to be x minus 1 times x plus 1 times x minus 1/2 minus square root of 23 over 2i. And unfortunately I ran out of room. I'm going to write it out front. The other one's going to be x minus 1/2 plus square root of 23 over 2i. Alright, if 1 plus 3i is a 0 of that, then 1 minus 3i is also a 0 of that. And you can actually do synthetic division using complex numbers. So we're going to have 1 plus 3i. And look at how it goes into 1, -2, 5, 10, and -50. So we'll bring down our 1, and then that's going to be multiply it times 1 plus 3i, and we just get 1 plus 3i. -2 plus 1 is going to give us -1 plus 3i. Now when we multiply this times this, they're actually conjugates of each other, because I could write this as 3i minus 1 and I could write this as 3i plus 1. So it's really going to end up being the first term plus times the first term plus the last term times the last term. So this is going to give us -1 plus 9i squared. That's -1 minus 9, which is -10. So 5 plus -10 is going to be -5. And now we're going to do 1 plus 3i times -5, which gives us -5 minus 15i. We're going to add that here with the 10, and that's going to give us 5 minus 15i. Now we're going to multiply 5 minus 15i times 1 plus 3i, and hopefully get 50. So we get first times first, plus outer times outer, plus inner times inner, plus last times last. So these cancel out. We have 5 minus 45i squared, which is 5 plus 45, which is 50. So our remainder is 0. Now we're going to put in our other root, which is 1 minus 3i. We're going to use all of this. So we have 1, I'm going to color code, negative 1 plus 3i, negative 5, and 5 minus 15i. This actually looks bad, but it's easier than the other one was. So I bring down my 1, and we multiply that times 1 minus 3i, which is just 1 minus 3i. Now when I add these two, I get 0. So 0 times 1 minus 3i is 0. That equals negative 5. Negative 5 times 1 minus 3i is negative 5 plus 15i, which gives us 0. So, whoa, what is happening? Not sure why all these white rectangles are going about this. So what we end up with is x. So I love my computer. It has a mind of its own. So what we end up here is x squared minus 5 is our last factor, and that equals 0. So x squared equals 5, and x equals plus or minus the square root of 5. So that's two of our zeros, and x equals 1 plus or minus 3i are our other two zeros.